Russian emergency officials issued their warning at 11:47 p.m. local time, just 16 hours after Sheveluch's eruption painted the sky black. They warned that a magnitude 9.0 earthquake could strike southeastern Kamchatka within 24 hours. Scientists analyzing seismic data from the eruption discovered that Sheveluch's explosion revealed stress patterns they had never seen before, patterns that suggest the Earth's crust is redistributing enormous pressure loads in real time. The 490-kilometer ash cloud was not just volcanic debris, it was a warning signal from the planet itself. So here is what is keeping seismologists up at night. If a magnitude 7.0 earthquake can trigger volcanic eruptions as a stress release mechanism, what happens when that stress keeps building toward a magnitude 9.0? And how many more volcanoes will receive their wake-up call before the shaking stops? Nestled at the junction of the Aleutian and Kamchatka volcanic arcs, the snow-capped peak of Sheveluch appears more like an isolated mountain than an obvious volcanic threat. Located 280 miles from major population centres, this deceptively serene volcano lulls tourists and locals into a false sense of security. As the indigenous Itelmen people know, Sheveluch translates ominously to smoking mountain in their native tongue. What lurks beneath this seemingly tranquil facade is one of Earth's most explosive secrets. Over the past 10,000 years, Sheveluch has unleashed over 60 major eruptions, earning it a ranking among Kamchatka's most dangerous volcanoes. Since 1999, it has remained in a continuous state of unrest, with measurable lava dome growth rates and daily thermal anomalies detected since July 2024. Despite its second highest aviation color code of orange, Sheveluch's true destructive potential remains hidden from the untrained eye. As volcanologist Dr. Olga Jirina warns, most people see a snow-covered peak. Volcanologists see a loaded weapon. Little did anyone know that on August 18th, an unseen force would pull the trigger from hundreds of kilometers away. August 18th, 2025, marks a watershed moment in our understanding of Sheveluch's destructive potential. At 7:45 in the morning local time, a magnitude 7.0 earthquake struck 280 kilometers away. Exactly 8 minutes and 14 seconds later, Sheveluch violently erupted. An ash column rocketed 8 kilometers into the atmosphere, blanketing an area of 490 square kilometers in volcanic debris. Pyroclastic flows, superheated avalanches of ash and rock, raced down the slopes at speeds up to 19 kilometers. The seismic waves that triggered this eruption traveled at a blistering 15,000 miles per hour through the Earth's crust, destabilizing a magma chamber estimated to lie 6 to 8 kilometers beneath the surface. Within minutes, over 200,000 tons of sulfur dioxide were injected into the stratosphere. Sensitive GPS instruments detected millimeter-scale ground deformations, betraying the immense forces at play deep underground. Teams from the Kamchatka Volcanic Eruption Response Team, the Russian Academy of Sciences Institute of Volcanology, and the Global Volcanism Program raced to analyze the unprecedented data. As seismologist Dr. Ivan Kulikov explains, we captured the exact seismic signature that destabilized the magma chamber. This changes everything we know about earthquake-volcano interactions. Sheveluch's explosive history reads like a volcanologist's worst nightmare. The catastrophic Plinian eruption of 1854, the largest in recorded history, was just a prelude to a century of destruction. In 1964, a massive dome collapse triggered devastating debris avalanches that reshaped the surrounding landscape, miraculously claiming no human casualties because the volcano is remote. Fast forward to April 11th, 2023, when Sheveluch unleashed its largest eruption in 60 years, launching an ash column 20 kilometers high. The paroxysmal phase blanketed an area of 108,000 square kilometers in ash, while pyroclastic flows raced 19 kilometers from the crater. The region's largest ashfall in 6 decades prompted assignment of the highest red hazard code, but it was the near-complete destruction of the 300 years of the Russian Academy of Sciences lava dome in November 2024 that truly set the stage for the August 18th seismic surprise. Increased seismicity, progressive dome instability, and sudden collapse showed that Sheveluch was following a script written over centuries, with major eruptions following from 50 to 400 years, and always preceded by dome instability and seismic swarms indicating magma movement. The crucial difference? In 2025, regional earthquake activity added a terrifying new plot twist. As one volcanologist ominously notes, the 2023 eruption showed us Sheveluch's destructive potential. August 18th showed us something far worse. External triggering can override natural timing. In the aftermath of August 18th, scientists are grappling with an unprecedented new threat: the proven vulnerability of volcanoes to distant tectonic events. Sheveluch's magnitude 7.0 triggering earthquake originated 280 kilometers away, far beyond the typical influence zone for volcanic interactions. This seismic coupling, previously theoretical, is now a chilling reality. Thermal anomalies, lava dome reconstruction, elevated gas emissions, and continuous eruptive activity all point to a volcano operating outside its natural cycle. Sheveluch is no longer an isolated threat, but part of a broader pattern of sensitivity detected across Kamchatka's 29 active volcanoes. Simultaneous monitoring alerts at multiple sites reveal a region on a hair trigger, with the slightest seismic provocation capable of unleashing synchronized destruction. The international scientific community has launched an unprecedented surveillance effort with the United States Geological Survey coordinating Pacific Rim observations, while Japanese and Alaskan seismic stations track the ominous propagation of stress across the Ring of Fire. Aftershock sequences from the August 18th quake continue months later, elevating the probability of a catastrophic magnitude 9.0 rupture. The 24-hour warning from Russian authorities, confirmed by multiple agencies, underscores the urgency of the threat. As one Russian emergency ministry official grimly states, external seismic triggering means Sheveluch is no longer operating on its internal timeline. Any major earthquake in the region could now accelerate eruption cycles. The implications extend far beyond Kamchatka, exposing a hidden network of instability linking the world's most dangerous tectonic boundaries. Imagine the seafloor 100 kilometers southeast of Kamchatka suddenly rupturing along a 500-kilometer fault line. A magnitude 9.0 megathrust earthquake, 32 times more powerful than the August 18th trigger, sends shockwaves racing through the Pacific crust at supersonic speeds. Within 8 minutes, those same seismic waves reach not just Sheveluch, but every volcanic system across Kamchatka. The stress changes are so intense that multiple volcanoes respond simultaneously. Sheveluch's rebuilt lava dome collapses catastrophically, generating pyroclastic flows that race down all flanks at 100 miles per hour. The nearby Klyuchevskoye complex erupts in tandem, creating dual ash columns visible from space. Ash clouds from multiple eruptions merge into a toxic blanket stretching 1,000 kilometers across northeastern Russia, launching millions of tons of sulfur dioxide into the stratosphere. Aviation across the entire North Pacific shuts down as the Bering Sea becomes a navigational nightmare of volcanic ashfall. The magnitude 9.0 earthquake generates tsunami waves that cross the Pacific in 9 hours, striking Alaska, Hawaii, and the US West Coast. But the devastation does not end there. Seismic energy continues propagating through the Earth's crust, reaching volcanic systems across the Ring of Fire. Alaska's Aleutian volcanoes show increased activity. The Cascade Range volcanoes in Washington and Oregon register unusual seismic patterns. With multiple major volcanoes erupting simultaneously, the combined atmospheric injection creates the largest volcanic climate-forcing event in modern history. Global temperatures drop by 0.5 degrees Celsius within months. Arctic ice formation accelerates. Crop yields across northern latitudes fail as growing seasons shorten. The economic fallout is staggering. The global aviation industry faces $50 billion in losses. Pacific shipping routes are disrupted for months. Electronic supply chains severed at Asian manufacturing hubs send shockwaves through every sector. Agricultural markets reel from simultaneous commodity price crashes and spikes. The insurance industry, overwhelmed by simultaneous catastrophes, teeters on the brink of collapse. As one emergency preparedness expert warns, a magnitude 9.0 earthquake would not just trigger Sheveluch, it could activate the entire Kamchatka volcanic arc simultaneously. They add that we have never modelled what happens when 10 major volcanoes erupt at once. The cascading consequences expose the terrifying fragility of our interconnected world in the face of geological forces beyond our control. What August 18th revealed is not just that earthquakes can trigger eruptions, it is that volcanic systems are connected by invisible stress networks, spanning thousands of kilometers. When the magnitude 7.0 earthquake struck, monitoring stations detected synchronized pressure changes at volcanic sites across the entire Kamchatka Peninsula. It is a discovery that challenges our understanding of the Earth's tectonic architecture. The culprit is the Pacific Plate Subduction Zone, a continuous stress field linking volcanic arcs from Alaska to Indonesia. When major earthquakes release stress in one area, that energy propagates through the crust like ripples in a pond. Volcanic systems act as pressure release valves in this titanic network. GPS stations recorded millimeter-scale ground movements at volcanoes hundreds of kilometers from the August 18th epicenter. These tiny shifts represent enormous stress changes in magma chambers already near critical pressure thresholds. The evidence mounted in real time. Abeco volcano in the Kuril Islands erupted 2 hours after Sheveluch. Seismic stations in Alaska detected distant stress wave arrivals. Japanese volcanologists issued precautionary alerts. As one Pacific Tsunami Warning Center scientist explains, we always knew the Ring of Fire was connected, but we thought the connections were slow geological timescales. August 18th proved they can be instantaneous. One major earthquake can now trigger a cascade of eruptions across continents. If volcanic systems respond to seismic triggers in real time, then every major earthquake becomes a potential catalyst for multiple eruptions. The Ring of Fire is not a collection of separate threats. It is one integrated system of planetary-scale destruction. The implications for global risk assessment are staggering. Our models, warning systems, and emergency response plans are built around local hazards, blind to the possibility of synchronized catastrophes. August 18th shattered that illusion of isolation. It revealed a world where the ground beneath our feet is more interconnected, more unstable, and more unpredictable than we ever imagined. The question is no longer if the next great earthquake will strike, but how many volcanoes will answer its call. The race to unravel the mysteries of the Ring of Fire has never been more urgent. The fate of millions may depend on it. Right now, as you watch this, seismometers across the Ring of Fire are recording thousands of micro-earthquakes. Each tiny tremor could be the precursor to the magnitude 9.0 megathrust that Russian scientists warned about. Each volcanic gas measurement could signal the next eruption cascade. The 24-hour warning window for Kamchatka's catastrophe is ticking down. But there is another volcanic system, one much closer to millions of people, that is showing the same seismic coupling signatures that preceded Sheveluch's eruption. Are we witnessing the beginning of a Pacific-wide volcanic awakening? Will our warning systems be fast enough to keep pace with the Earth's hidden networks of destruction? These are the questions that will define our future in a world where tectonic stability is an illusion. The answers may come sooner than we ever imagined. That is why we need your help to track these global patterns. Share your observations, subscribe to Earth Attacks, and stay vigilant because the story of our planet's interconnected destiny is far from over.